Okay, well, welcome everyone. I'm really glad to be doing this talk here. I'm going to be talking to you about ecosystem services provided by aquatic insects. This is based on a paper that Jenny Stockin and I wrote. Jenny's from the James Hutton Institute in Aberdeen, and we prepared this paper to look at just all the different services provided by aquatic insects. Before I start, just introduce myself. I'm Craig Macadam. I'm Conservation Director with Buglife, the Invertebrate Conservation Trust. Buglife is the only organisation in Europe concerned with the conservation of all invertebrates. We cover everything from mayflies to millipedes, starfish to spiders, and our aim is to halt invertebrate extinctions and achieve sustainable populations of invertebrates in the UK. We have various plans and strategies that we are working to. We have a freshwater strategy which has 8 broad principles that are aimed at protecting freshwater habitats and the invertebrates that inhabit them. The one I'm going to be talking under is the first one here, which is that aquatic invertebrates should be understood, cherished and properly valued. So I'm going to talk about ecosystem services. So to start off with, I'm just going to go over what an ecosystem service is. So the UK National Ecosystem Assessment, which was published in 2011, defined an ecosystem service as an activity or function which provides direct benefits to humans. It also defined goods as the objects that are valued through experience, use or consumption. So these are part of an ecosystem service, but they're defined as goods. The ecosystem assessment goes on to describe 4 different types of ecosystem service. So the first one is provisioning services, ones that produce material benefits from ecosystems. We have regulating services that are benefits obtained from the regulation of other services. Supporting services, these are the services that are necessary to produce other services in the provisioning and regulating categories. And then the final one is cultural services. And cultural services is a kind of catch-all for all those things that we really value, but we don't really get material benefits from. And as we go through this talk, I'll speak about different categories in all these services, different services from each of these categories. As you'll see, the cultural services are actually one of the biggest services that we get from aquatic insects. We'll start off with the provisioning services, so those material benefits we obtain from ecosystems. And these are the sort of things that we directly use as humans. And the first thing I'd like to talk about is aquatic insects as food for humans. So Jenny and I did another study which looked at this, and we collated information about all the insects that were eaten as, all the aquatic insects that were eaten as food around the world. And we got this impressive list of 223 species covering each of the aquatic insect orders. We looked in recipe books, we looked in Google searches. It was quite interesting that it wasn't a normal literature search where you went and looked at scientific papers. There was a lot of traditional uses that weren't documented in scientific papers. We found that the beetles were the most commonly eaten aquatic insects with 79 species. Dragonflies and true bugs were equally quite high in number of species. And then the smaller orders, the mayflies, stoneflies, caddisflies and alderflies were less well represented. If we look at where across the world these insects are eaten, we see quite an interesting split between the southern hemisphere and the northern hemisphere. So in the southern hemisphere, there's the widest diversity of species eaten, almost certainly reflecting the importance of the insects in the diets of some people in these countries. The northern hemisphere has fewer species eaten, but there can be high numbers of species used, particularly the further east you go into Japan and parts of China. But we can see there the general split. And just to give you an idea of some of the species that are eaten, if we look at mayflies first, so mayflies are high in proteins and minerals and vitamins, and they're eaten in several places around the world. In China, the mayfly Telegonopsis jinghongensis is eaten fairly commonly. It's thought to have the highest raw protein content of any edible insect at about 66%. In South America, the 17th century Incas were reported as feeding on Lithoplecia species. In New Guinea, there's reports of Plithogenesia being eaten. But perhaps the place where mayflies are eaten most is in Africa, where there's two species that are eaten alongside Diptera as they hatch off the big lakes in Africa. So in Lake Victoria, Lake Malawi, and we get Pavilla robusta and Canis kungu hatching from there. Other species, dragonfly nymphs, are also high in protein, and there's several species around the world. Crocothemis, Gomphus and Lestes in China. The global skimmer is eaten in Java, Pantala flavescens, and Trithemis in Africa. Perhaps the two main groups, though, that are eating in these areas is the Chaeobrus midges that come off Lake Victoria regularly in huge numbers, and are collected by locals and made into a patty, along with those mayflies, and also the shore flies that Native Americans used to eat in North America, Ephedrydra hyans. They used to do the same sort of thing, collect them as they hatched, and then make them into patties. One of the most spectacular species that is eaten around the world is the giant water bug, Lithosiris. Now you can see the size of this. This is a big insect, and this is eaten all over Asia. It's gathered by farmers at night from around lights. It is then roasted and eaten as a delicacy, and it's so popular that it's now exported around the world. So it's exported from Thailand, for instance, into Asian food shops in the US. The exploitation of this species is so great that it now has to be imported into Thailand from neighbouring countries such as Cambodia and Laos to satisfy this demand. And it's a real potential conservation issue here that the species has been exploited that much. Moving on to regulating services, these are regulation of other processes in the ecosystem, and the one that I want to talk about is filter feeding. Now, filter feeding insects are the majority of the caseless caddis are filter feeding insects, plus some of the cased caddis, like these granum larvae here, the Brachycentrus subnubulus. You can see here the one on the screen, the several ones on the screen have got their legs up in the current. The current's coming from right to left, and these legs have got tiny hairs on them that capture particles which they can then pull down and feed upon. Several other species will feed like this by filtering out particles out of the current. Here's two mayfly species. So the top one is Arthroplea, which has these specially modified mouth parts which have fine hairs on them as well to capture particles. And in the bottom there is species like ephemera and hexagenia will create a burrow and force water through that burrow, which brings particles in there for them to feed upon. probably by far the greatest number in some rivers in the UK in terms of filter feeders is the blackfly larvae. Now, these are blackfly larvae here attached to the side of an aquarium, but normally they'd be attached to stones and things on the bed. And they can be really numerous, hugely numerous, you know, hundreds and hundreds of them in a stretch of river. And they have adapted mouth parts, these fan-shaped mouth parts, which they wave in the current and then bring that down and feed upon it. So they're capturing a lot of tiny particles of various detritus and the like, and helping to clean the river. Caddisflies also have important other effects on the sediment in the watercourse. The casus caddisfly shown here, Hydropsyche, creates a fine net out of silk in which they filter out tiny particles of organic matter that they can feed upon. But the nets also bind together all the grains of sand around about it, and together bind it all together and help to stabilize the bed in that area. And caddisflies larvae that create their own case rather than just a shelter bind even more of that sediment together. Research at the University of Nottingham found that in a 2-kilometre stretch of river, there were estimated to be around 128 million caddisfly cases, and that was fixing about 8 tons of fine gravel, which when you magnify that up to a whole river system, that's a huge amount of gravel that has been fixed by these caddisflies. Supporting services. So supporting service, if you remember, were the services necessary for the production of other services. So in this case, it may be that a different species may feed upon on the insects, and then we use that species, or it may be another thing that happens that we then use perhaps for tourism or whatever. When we look at the main thing, the main supporting services as food for other animals, and as the title of the talk says, that want to look at them as more than just fish food, but in this case, let's look at them as food for other animals. We looked at, there was a study done by Peter Grant on in particular just looking at mayflies and looking at the different species that fed upon mayflies, and we expanded upon that to look at other aquatic insects as well, and we documented 339 predators of aquatic insects. There's probably a lot more that we didn't document. The main ones here are shown in this pie chart with fish and other invertebrates, like the dragonflies or stoneflies or the like, producing roughly about 3/4 of the species that are actually feeding on aquatic insects. Birds come in there as well, so things like the dipper or grey wagtails that are feeding on aquatic insect adults. Amphibians and reptiles feeding on them as well, both in their larval stages, and then mammals, 12 mammal species, mostly bats, which were feeding on aquatic insects in the adult stage. Just to give some idea of the importance of aquatic insects, so this is a couple of statistics about the overall contribution of mayflies alone to the diet of different fish species. So the velvet cichlid is almost entirely feeding on mayflies. 98% of its diet is mayflies. Freshwater stingray and shining catfish, also high proportion of the diet is from mayflies alone. And why is that important? Well, because a lot of these species have a commercial value, or they are fished for, and there's a separate service that is provided by the fishery, if you like. Fishing is a hugely popular sport, and the quote at the top there that says, "Who has not seen the scarus rise, decoyed and killed by fraudful flies," was actually from a 1st century Roman poet called Martial, who described fishing even that long ago. and various assessments have been made since of the economic value of fly fishing. So freshwater fisheries for game fish in Scotland, so that's salmon and trout, was estimated to be worth £112 million per year. In England and Wales, the same sort of assessment came up with a figure of 386 million. And in West Virginia, in one state alone in the USA, it was $333 million per year. The number of anglers in some of these areas is huge. If you look at the in the US, 25.4 million people taking part in freshwater fishing, not necessarily all for trout or for fish that are feeding on invertebrates, but still a huge number of people. And the individual value of a trout stream, a mile of trout stream in West Virginia, was estimated at 74,000 per annum. So again, a huge contribution, and this is all based on aquatic insects, aquatic invertebrates as food for these fish. Another supporting service is the is keeping the river clean and healthy. So what I want to talk about in this slide is bioturbation and bio-irrigation.
Sorry, Craig, can you unmute yourself, please?
Why did I mute? When did I mute? That okay?
Perfect, thank you.
Right. Yeah, bioturbation and bio-irrigation. So bioturbation is the churning of the disturbance of the gravels in the bed, the sediments in the bed of a river or a lake, and that is important so that water can get through there, that bio-irrigation, so that water can actually get down there and oxygen can get down there to stop it from going stagnant in the gravels. And this is something that a few different groups of insects do. So the non-biting midges up in the top left there, this is Chronomist Plumosis, and it will burrow into the top layers of the sediment and create that irrigation, and it's been shown to increase the levels of nitrification that are occurring in the river, and that's the conversion of ammonia to nitrites and nitrates, so the process of actually cleaning up any nutrients that are in there. Also the excavation of Caddisflies, such as the one on the right there, which is a US species, which burrows down in, taking that leaf litter down there. It'll break down other buried leaf litter in the sand that it lives in as it feeds upon it, and it basically reworks all those sediments round about it. Other species that will do that are likes of the Welshman's button, Sericostoma personatum, another caddisfly. The gold ring dragonfly, its larvae will go into the gravels and do that whole disturbance of the gravel and reworking of the gravels. And then the mayflies such as ephemera and hexagenia, which make that burrow that you can see on the bottom left there and actually get water down into the gravels. Okay, so the last supporting service that I want to cover is the use of insects for feeding other animals and particularly livestock. And anybody that's seen my presentation, I usually include this photo because it's the photo that got me. Here's that up again. Wait a minute.
So yeah, if you stop your sharing and restart it, and it should give you an option for just the presentation, not your screen.
Okay. Still coming up. Can you see that? Can you see?
I can still see that block. I don't know what's happening. If you can't solve it, don't worry too much, but yeah. I
hide it and then it comes back up. Right, I'll keep going. You're just missing the titles, I think, when it comes down. Yeah, so supporting services. Another supporting service is the use of aquatic insects as feed for livestock. And yeah, anybody that's seen one of my presentations, I usually include this this photo, because this is the photo that really got me interested in aquatic insects. I could not believe that that there could be so many insects present at the one time. You know, this guy is actually driving across a bridge across the Mississippi, and he's having to move mayflies out of the way so he can get his car along the road. And you know, they're crawling up his legs. They look like iron filings on the bonnet of his car. It just fascinated me as a kid that this happened. But along the Mississippi, they will, you know, put on air raid sirens to tell people to close their windows. They'll use snow plows to get these out of the way, and they kind of just decompose on the side of the road. Whereas they could be used, they're a huge source of protein, so there's a great potential for them to be used as a source of protein, as a source of food for livestock. So moving on from the supporting services to the cultural services. They were the non-material benefits. So they are the things that we enjoy and we cherish and we love about these insects. And what I'm going to do is I'm going to go through 6 different categories. I'm going to go through the use of aquatic insects in literature, the use, our giving common names to them, the use in music, art, in the naming of things in technology, and then some examples of marketing that is used aquatic insects. Start off with literature. The earliest references to aquatic insects are really quite old. They can be found in the Epic of Gilgamesh, which dates from 2000 BC. It's an epic poem which chronicles the life of Gilgamesh, a Babylonian ruler from around 2700 BC, who thought he was immortal, would live forever, and you know, he thought he was undefeatable in battle. And this epic was written on a series of clay tablets, one of which describes the briefness of Gilgamesh's life, likening it to that of an adult mayfly. So ever the river has risen and brought us the flood, the mayfly floating on the water, on the face of the sun its countenance gazes, and then all of a sudden nothing is there. And it's talking about this short adult life of the mayfly, and that Gilgamesh was just, his life would be just as short. He wouldn't live forever. Quite surprisingly, you know, there's been a little bit of work to look at what species this might have been. And it's thought that we actually know what species of mayfly this was. There's other contemporary works talk about water locusts, but actually to describe the behavior of a mayfly, and the behavior of a particular mayfly which emerges in huge numbers in the time of year that the floods would be happening on the Euphrates River. And we actually think it could be this species here, which is now Motogenesia Mesopotamica. And this was described in 1921 from the area where the epic was set. The description that was in an English paper, in an English journal, and the actual specimens that it was described from, the type specimens, are in the museum in Edinburgh, in the National Museums of Scotland. And these are the slides that it was prepared from here. And you can actually see where the picture at the top of the left-hand column has been copied from the slide second down. Next up is Aristotle, who was a bit closer to modern days, but still in the BC, 350 BC. He wrote about the insect that lives and flies about until the evening, but as the sun goes down, it pines away and dies at sunset, having lived just one day. So again, quite probably a mayfly, talking about its short adult life again. Coming a bit closer again, we have Claudius Aulenius, who was a poet in ancient Rome who described speckled fish feeding on flies that hover above the river Astraeus. We think that's probably this species here, which emerges in huge numbers but keeps very close to the river and moves up and down the river, and would potentially look like it was hovering. Much closer to our own time, in the UK, mayflies and their relationship with humans through fly fishing has featured in a huge number of literary works. This is a poem by Patrick Chalmers called To an Old Friend. It was published in 1914, and it describes the thoughts of an angler and speaks to a trout as he finishes off the season, the fishing season. And he describes, in the last verse, he describes meeting him again when they come together to meet the first March brown. So that's a species that emerges right at the very start of the fishing season. Fishing, as I mentioned, fishing and aquatic insects goes together really hand in hand. And one of the early descriptions of fishing was in 1486 by Dame Juliana Berners. She was the abbess of St Albans. She described the whole art of fishing in the Book of St Albans in a treatise, which was the Treatise of Fishing with an Angle. So the birth of angling, I suppose, as a term. And she described the tackle you should use, when you should fish, what the fish were feeding upon, and how to imitate them. So she actually described a number of artificial flies and gave them common names. So here's some of the ones that she described. She's described in March, you should fish for the dunfly with a body of dun wool and the wings of partridge. And that's almost certainly Rithogena germanica, the March brown, which has these speckled wings, which is similar to the speckled feathers of a partridge, but it could be Ecdionus torrentus, which comes out a bit later in March. In May, she talks about a yellow fly, the body of yellow wool, the wings of red cock's hackle, and of the drake dyed yellow, definitely a yellow fly. And we have a fly in the UK which we call the yellow May dun now, Heptogena sulphurea, which is almost certainly the one that she was talking about here. And the final one here is the duncut, the body of black wool, a yellow stripe along either side, the wings of the buzzard bound on with hemp that's been treated with tanvac. So a dark fly with a yellow stripe. And we have this species here, Electrogena lateralis, which is called dusky yellow streak by anglers now, but it has this yellow stripe below the wings on an otherwise dark fly. There's many other common names for aquatic insects. I mean, almost all of them have common names now. But here's a selection of them from the mayflies and stoneflies. We have things like the March brown we've talked about, turkey brown, green drake, yellow sally, widow stonefly. Some of the reasons for these names, so some of the meanings of these names have been lost in time, I suppose, but they do bring a lot of colour and connection to people with these insects. So moving away from common names and literature into music, there are several musical outfits that are named after aquatic insects. So there's a rock band in North Carolina called the Mayflies, and in France there is a Mayfly Symphony Orchestra. The Mayfly Palingenia longicorda, which we will see later on, the Tisa Mayfly, is mentioned in a Hungarian folk song as a symbol of man's love. Fleetwood Mac based a song on W.H. Davies' poem The Dragonfly, and less famously, the Croatian band Dragonfly featured in the preliminary stages of the Eurovision Song Contest in 2007. They didn't get very far. Of course, stoneflies are accomplished drummers in their own right. They drum their abdomen against a surface to produce a signal to attract a mate, and they can have quite elaborate patterns of drumming. And this inspired myself and Scott Matheson, a colleague, to include their rhythms in a musical compilation. So I recorded the stoneflies, and Scott then put them as an accompaniment to a piece of music, and the result is available on SoundCloud, and we'll get the link into the chat at some point during this talk. It features 5 different species of stonefly and their drumming. Into film, you may not think of Jurassic Park as being based on aquatic insects, but it is absolutely based on aquatic insects. So if you remember the story of Jurassic Park, that the dinosaurs were all created from the blood of a mosquito that was found in a piece of amber. Here's the piece of amber here that was featured in the film. It's a great story, but if you actually look closely at the mosquito that is used in the film, it's a male and it wouldn't feed on blood. So it's a little bit of artistic license, perhaps. Moving into art, many artists have used aquatic insects in their work. Some of the more famous ones are Clara Driscoll, who worked for Tiffany & Co. She designed the Dragonfly lamp in the early 1900s, and it's still one of the best-selling designs of the Tiffany company. Moorcroft also did a range of pottery based on mayflies. These are fairly expensive now. They're lovely pieces. I've not got one, but I'd love to have something like this. It's great to see mayflies on a piece. René Lalique often incorporated dragonflies into his work, and one of his most famous pieces was the Dragonfly Woman, which was a corsage that he designed for the actress Sarah Bernhardt. It's a beautiful piece. And then some artists go a step further. They actually get the insects themselves to create the art. The French artist Herbert Dupré uses Caddisfly larvae to create his artwork. He removes them carefully from their case, and they start to build a new case, but he puts them in a tank with some gold and silver and other precious stones and precious metals, and allows them to build their case before again removing them and putting them back into a natural substrate. And the results are stunning, although I'm not really sure about the ethics of doing this, because it must stress the insect in some way. But every design is unique. He doesn't sell them, he exhibits them, but there are certainly in the US, there's people that actually sell caddisfly jewelry, or jewelry made by caddisflies. I talked about the Palangenia longicorda, the Teaser mayfly, before. This is the individual here, and it is celebrated throughout the Danube catchment where it occurs, particularly in Hungary, where there's the love song, as I said. There's festivals for this species, whole range of different activities, and it's also the inspiration for a bridge over the River Tisa in Hungary. So the Tisa Virag Bridge, means the Tisa Mayfly Bridge, is in Szolnok, and is designed to resemble a mayfly with its wings outstretched, and to celebrate this mayfly, which is the largest in Europe. It looks lovely, it looks wonderful, but the lighting kind of defeats the purpose, I think, because it will affect the behavior of the mayfly in the water and when it emerges. So it's perhaps a bridge too far. Moving into technology, we're moving into from architecture, I suppose, to technology. There's a range of different vehicles that have been named after aquatic insects. This is a very early attempt at flight called the Seddon Mayfly. It was it was designed by Lieutenant John Seddon of the Royal Navy, who was inspired by a paper model that had been made, and he hoped to win a £10,000 prize for the first Manchester to London flight. He made it out of tubular steel, built it in a bicycle factory, and it was designed to carry five passengers, but I really don't know where they would have sat. He named it Mayfly, and that was perhaps prophetically or optimistically. When it ran for the first time at high speed, it lost a wheel and it broke up, and then it wasn't repaired. They didn't have another go at it because the war intervened. But it was one of the first aircraft to be named Mayfly. Lillian Bland also designed a plane which was a bit more successful. It did fly at least, and the Bland Mayfly was designed by Lillian Bland from Northern Ireland, and she was credited as the first. It was credited as the first aeroplane that was designed and constructed by a woman. Moving into the modern era, or more modern era of flight, there's the de Havilland Dragonfly, which was a luxury touring biplane, first introduced in the 1930s. Another Dragonfly was the Cessna Dragonfly, which was an attack aircraft in the US Air Force. And then we have the very first British airship produced, constructed. So His Majesty's Airship No. 1 was designed by and built by Vickers at Barrow-in-Furness in Cumbria. She was the first British rigid airship, and whilst it was attached to the tender HMS Hermione, so it should have been called HMA Hermione. She was called Mayfly by all the lower deck, the non-commissioned component of the ship's crew. Perhaps again prophetically, because when she was moved from her shed in the docks to conduct full trials in September 1911, she broke in two because of the strong winds, and she wasn't able to attempt her first flight, so she definitely didn't fly. Moving on to the sea, we have the Dornier Libelle, which is Libelle is German for dragonfly, an early flying boat from the 1930s. We have a whole series of warships that have been named after aquatic insects. This is HMS Mayfly, which was a fly-class river gunboat in the First World War, and other fly-class boats included the Blackfly, Dragonfly, Caddisfly, Stonefly, a whole range of different species. The final bit I want to talk about is marketing. So aquatic insects have been used to sell various different products or entice people into different stores. Here in the UK, there's many inns and pubs that are named after mayflies. They're typically around about areas where there's lots of fishing, like the chalk streams, although some of them aren't necessarily related to the insects. So some of the pub boards at the bottom there show you the different uses. So there's the airplanes, Lillian Bland's Mayfly on the left. I'm not sure why the Spitfire's there, and then a fishing fly on the right. There are breweries named after aquatic insects. So there's Stonefly Brewery in Milwaukee. There's a Stonefly IPA in Pennsylvania, Stonefly Rye Ale in Oregon. In the UK, there's Mayfly Bitter, and then a Mayfly Pale Ale as well. There's a whole range of different beers made by a Swedish brewer, and based on the Mayfly life cycle. We've got Mayfly, Nymph, and Emerger there, and we've even got a Californian brewer that uses the Latin name of a Mayfly as the name for its IPA. In London, there's a Dragonfly brewery, and the micro brewer from the notebook have a golden ale called Golden Ring Dragonfly. But perhaps more unusually is the Badger Brewery in Dorset, which has had a beer named after the Blandford fly. So the Blandford fly is a blackfly, Simulium pusticatum, which bites a lot of people, causes a lot of swelling and like around the area of Blandford Forum, and it was named the Blandford fly. Badger Brewery created this ale with ginger in it, and marketed it as an unusually fresh premium ale, subtly spiced for extra bite, perhaps presumably hinting at the activities of the fly. And it's also interesting that the fly is actually shown on the label there.
I've obviously missed most of it.
Over the years, its marketing has changed, so it became Blandford fly, and the fly was removed from the label, and a fly fisher was put on there instead. But it still said about for extra bite at the top, and there was a little fly up there. And then, but nowadays it's no longer Blandford fly; it's now called Blandford flyer. Perhaps the idea of having a true fly on the label or in the name was just too much, and it's now linked to an artificial fly for fly fishing. Nike produced a range of ultralight running shoes called Mayfly. These were designed like their natural namesake to have a limited life. So they were designed to be able to run in them for 100 kilometers, and then they would be done. The shoe design features a wing venation pattern, which they say is that of a mayfly, but that looks a bit more like a dragonfly to me. They weren't the first footwear manufacturer to use aquatic insects in their naming. About a decade earlier, Italian designers Andrea Tomat and Adriana Sartor launched a brand of shoes called Stonefly, and you can still get these shoes nowadays. And Raleigh had a range of mountain bikes called Stonefly as well, which I think they still produce nowadays. The final thing that I want to show you is, I'll talk to you about, is TV marketing. So Vodafone, the mobile phone company, ran a branding campaign featuring mayflies back in 2006. The television advert encouraged viewers to make the most of now, just like the mayfly has to as an adult, because it only lives for this single day. And the campaign is thought to have cost around £100 million, and it won several awards. It was very popular. They had a website that you could put in how you were going to spend your day and make the most of now. And what I'm going to do to finish off is just show you the video, which hopefully will play.
The common mayfly has a life expectancy of just 1 day. But is he miserable about it? Not one bit. He fills his day with the things he loves. He soars, he swoops, he savours every moment. Maybe there's a lesson in this for us longer living creatures. Just think, if we embrace life like the mayfly, what a life that would be. Vodafone, make the most of now.
Thank you.
That was brilliant, Craig. Thank you. We've got a few questions in the chat. There was a bit of a heated debate about the ethics of feeding insects to livestock, which I'm not going to touch. But yeah, that's happening in there. I never realized how many people who like invertebrates also like their alcohol. As soon as you started talking about different types of ale and beer, everything just like it all kicked off and the chat got crazy. Got a couple of questions though that might be worth revisiting. So Rachel asks, can you give a quick description of what bio-irrigation is?
So bio-irrigation is, that twin thing where the disturbance of the gravels, the sediments, and the reworking of those sediments allows more water in, so allows water to filter through those gravels. And so that's the irrigation bit.
Amazing. And I've got one from Michaela who asked, how on earth did you go about researching references to insects in literature? Because that's bizarre anyway, isn't it?
Yeah. So we did the normal sort of scientific literature, if you like, which is fairly easy to do. There's systems that you can use to search scientific literature, and then it was really a case of lots of Googling. Just going in and searching for stuff and asking other workers if they'd heard of things, because it's the sort of thing that people if you say that you work on mayflies or dragonflies, I say, oh, do you know about this? So yeah, just lots of just asking, really.
I've got one from James who asks, I hear that insect numbers are reducing and wondered if the same is true of aquatic insects.
Yes, it is true. It's a whole different talk. There's quite big declines in some groups. Caddisflies have shown, I think one of the studies I saw, so 58% decline in caddisflies. Certainly numbers fluctuate in the UK. Numbers fluctuate, but there's generally potentially a sort of decline in their range. So that the ranges are shifting. And then their numbers are determined on water quality, really. Water quality is a lot better than it was in the 80s or 70s, but that can change quite quickly if there's a pollution incident or something like that.
Cool. I've got one from Rihanna. I'm not sure quite what she's asking, but you might. She says, you mentioned technology that's been based on aqua invertebrates. Do you know of any filtering process that's used to remove them from the water when the water goes into homes?
I'm not 100% sure. So if there's, I don't know of any filtering technology that is based on what the insects do, or whether I'm not sure there's any that have been based on their techniques. And there is, or the other possible question there was, how do you stop them getting into the water supply? Which there's various filters in the water treatment works which will stop that. They're actually used. Water treatment in itself, the older or bigger water treatment works have things called slow sand filters, and within them are, a whole ecosystem of aquatic insects that are keeping them clean and keeping algae off them and things. So, things like species like non-biting midges are in those filters.
I've got a comment from Janet who is saying, one, it's in a fantastic talk, but she's very jealous of all the names of beers that we get in England because she's in Canada and she doesn't get that.
Need to speak to a brewer, Janet. Get them to do one for you.
Emma's got a question that you might be able to help with. What can be done to ensure invertebrates, both aquatic and terrestrial, are obligated as part of the ecological surveys, which are carried out for land management?
Gosh, that's another whole presentation's worth. So, the main thing is that at Buglife, we're trying to push for that. We're producing various materials. We've got a series of important invertebrate areas across the UK, and we're making sure that planning authorities are aware of them so that they know that there is importance in their area. We are we comment on planning applications, particularly in those important invertebrate areas, and make sure that surveys are done so that we can find out more about what invertebrates are present, and then make sure that the developer and the plans actually reflect that and act on what's found.
Off the back of that, we did a series on insect conservation and about assessing sites and things for invertebrates. So I'm going to whack that link in there. I think it's a series of 4 45-minute talks. So there's definitely one in there that might be related to that. So I popped that in. I have one question that's popped up. Do the needles of pine trees affect the acidity of water that they're around at all?
Yeah, so pine trees the needles are acidic. You need a lot of them, but if you've got a area of conifers, then yeah, you may have acidification downstream of it. But typically, it's a long. You need a big area for it to make a big impact. Geology is more of an issue with acidity when you get acidic geology like granites and things.
Awesome. I'm gonna leave it there. What I'm gonna do is I've put your links to your Buglife Twitter, but also your Twitter itself. So if anyone got any questions that might go off the back of that, they are welcome to tweet you, I assume. Craig, is that okay?
Yep, absolutely fine.
That's fine. That'll be in there, but they'll also be in the follow-up email off the back of this as well. But yeah, thank you ever so much for doing this today. It's been really interesting. I haven't really thought about a lot of insects in this way, and actually they supply lots of different services, not just ecological or whatever. So yeah, fantastic, and thank you for your time, Craig. And if everyone just like to say goodbye, you are welcome to, and we'll leave it there.
Thanks very much for asking me to do the talk.
You're more than welcome.
Thank you.
Thank you.
Thank you very much.